Hey, I'm Mitchell, and welcome to another video in the RSP Education series. What if I told you that your industrial motor is always running late, but on purpose? In the world of automation, precision is everything, yet electric motors are designed to slip. Why? Because without slip, your conveyor belts wouldn't move, your robotic arms wouldn't lift, and your packaging lines would fall apart. Today, we're going to dive into the high-speed chase between magnetic fields and rotors. We're going to uncover how synchronous speed, slip, and rotor dynamics work together to power the most critical systems in automation. If you like this content and want more educational videos, please like and subscribe. Also, this video is for educational purposes only. Consult a professional for your application. RSP Supply is not liable for any misuse of this information. With that said, let's get into it. So synchronous speed is like the theoretical top speed of the magnetic field inside an AC motor's stator. Think of it like a treadmill speed setting. If the motor were perfect and frictionless, this is how fast it would run. In industrial automation, machines rely on precise timing, and so synchronous speed helps define expected speed in automation tasks, like conveyor belts, pump motors, or CNC machinery, where timing is crucial. Slip is the difference between the synchronous speed and the actual speed of the motor's rotor. Slip happens because in induction motors, the rotor needs to chase the rotating magnetic field, so to speak, created by the stator in order to generate torque. If it caught up completely, like if it ran at synchronous speeds, the rotor and the magnetic field created by the stator, there'd be no relative motion between the stator field and the rotor, and then obviously no torque. A 3.33% slip is pretty typical in many motors. Slip tells us how efficient a motor is and how well it's responding to load. If slip increases unexpectedly, it can mean your machine is overloaded, or there's slipping belts, or something is wrong mechanically or electrically. Now let's talk rotor dynamics. That's basically looking at how the rotor behaves when it's spinning, and that's vibrations, balance, resonance, bending, etc. This is very important in high-speed or high-precision automation systems. Mass imbalance is if the rotor isn't balanced, it's going to wobble like a bent wheel. Critical speed, that's the rotor having certain speeds where it naturally vibrates. These are called resonance points, and running near them can destroy the motor. Bearing stiffness, this affects how vibrations are absorbed or transferred. Damping is to help reduce oscillations after load changes. So a real-world analogy, think of spinning a fidget spinner, right? If it's perfectly balanced, it spins smoothly. If there's a gum wrapper on one of the blades, it's going to wobble and vibrate. That's poor rotor dynamics. In automation, poor rotor dynamics can increase wear and tear, mess with sensor readings, throw off control loops, and cause unexpected shutdowns. In critical automation setups like robotic arms, centrifuges, or high-speed packaging machines, rotor dynamics must be tuned precisely for performance and longevity. How they all tie together in a typical industrial automation setup. So you're going to program a VFD, a variable frequency drive, to run a motor at a certain speed. That motor has a synchronous speed, but due to slip, it runs a little slower. As load changes, for example, let's say a conveyor belt fills up, slip increases and the rotor has to adjust. Meanwhile, the rotor needs to stay stable and balanced to avoid damaging vibrations. So let's bring it all together. Synchronous speed sets the pace. Slip shows us how motors generate torque and respond to load. Rotor dynamics make sure that the system doesn't shake itself apart. Together, they form the backbone of motion control and automation. Get them right and your machines hum with precision. Get them wrong and you're one vibration away from downtime. Stay tuned, stay sharp, and keep your systems in sync. For hundreds of thousands of other industrial automation products, go to our website. That's rspsupply.com. The internet's top source for industrial hardware.